Okay, welcome back. This is question 3 of 2017 November grade 10, paper 1. I'm going to do all of this question in this video. You could pause it and try it yourself first. I think that's the best way to learn. And then watch what I do. And let's start in with question 3.1. Consider this linear sequence. That's a key word in this problem, linear. A linear sequence means that the sequence increases by a constant, and we're supposed to find b. So we need to look for the pattern, and I see that I am adding 3 to each term to get the next one. So 11 plus 3 is 14. So b is equal to 14. Determine the nth term of the sequence. So now I really need to understand the pattern. The nth term, well, the first term was 5, the second term was 8, the third term was 11, the fourth term was 14, and because I know it's a linear sequence, I do know that we can say that the nth term will be the first term, and then we have to multiply that difference by n minus 1. So d would be that difference, the common difference. T sub 1 is the first term. T sub n is the nth term. This is a logical formula that we have to take the first term, which in this problem was 5, and then add to it n minus 1 times the difference, which is 3. We can simplify that formula for the nth term by distributing the 3 and combining our like terms. And you'll notice this form is the same as a linear equation like that, which you may have used instead of the formula that I used, where 3 would be the gradient of that linear equation. So to find the 15th term of the sequence, we can just use our formula. This would be the symbol I would use for the 15th term. That just means that n is equal to 15, and we're looking for t sub 15. So t sub 15 would be 3 times 15 plus 2, or 47. 3.1.4, which term in the sequence? That means find n, because n represents the number, the position of the term. So we can use our same formula. T sub n is equal to 3n plus 2, and we're interested in the n value when t sub n is 83. So we get 3n is equal to 81, n is 27. So the 27th term is 83. (3.2) is also a pattern question. And there are a lot of different ways to do this problem. If you use your calculator, you can actually just follow the pattern and find it. But I noticed that both the questions 3.2.1 and 3.2.2 are really about the sum of the numbers in the row. So the first one is the sum of the numbers in the 8th row, and the next one is the mean of the numbers in the 20th row. Well, if I know the sum of the 20th row, I can divide it by the number of terms in the 20th row. So it really is related to the sum of the numbers in the 20th row. So I might look for that pattern. If I look at the sums of the first and second row and third row, I get 2, and then 16, and then 54, and then 128. And it might not be obvious to me at first what the pattern here is, but if I've studied different patterns and I've noticed I know my squares and my cubes, I might notice that each of these is just 2 times a perfect cube. It takes practice to recognize these, but I see that this one is 2 times 1 cubed, the next is 2 times 2 cubed, then 2 times 3 cubed, and 2 times 4 cubed. And this was our first row, our second row, our third row, our fourth row. So the 8th row must be 2 times 8 cubed, which we know is 1024. We can use our calculator for that. And now in terms of the mean of the 20th row, if I could just find the 20th row, doing the same thing, the sum of the 20th row certainly is going to be 2 times 20 cubed. And then we will divide by the number of terms in the 20th row, which is 20. If you look at the rows, they go, there's 1 in the first row, 2 in the second row, 3 in the third row. So we'll have 20 terms in the last row. And if we simplify that, we get 800.